Have you ever looked up at the night sky and wondered if there is a hidden order to the cosmos, a secret mathematical blueprint that governs the dance of the planets? For centuries, astronomers and thinkers have searched for such a pattern. From Pythagoras' music of the spheres to Kepler's laws of planetary motion, we've been captivated by the idea that the universe isn't random, but is instead built on a foundation of elegant harmony. Today, we're diving into a fascinating modern take on this ancient quest. We're going to explore the work of Szilard and Gerby, an independent researcher who proposed a compelling hypothesis about the architecture of our solar system. His idea connects the spacing of the planets to a special mathematical constant you might not have heard of, the silver ratio. So, what exactly is the silver ratio? Many of us are familiar with its famous cousin, the golden ratio, which appears everywhere from art and architecture to the shells of nautiluses. The silver ratio, denoted by the Greek letter delta S, is similar. It's an irrational number, approximately 2.414, derived from a simple equation. Just like the golden ratio, it's found in nature and mathematics, often appearing in patterns that exhibit a specific kind of recursive growth. This is where Gerby's hypothesis comes in. He noticed something remarkable when he looked at the distances of the planets from the Sun. He proposed that the spacing between planetary orbits is arbitrary but follows a geometric progression based on this very silver ratio. Let's break it down. Gerby's model suggests that if you take the distance of one planet's orbit, you can predict the distance of the next one by applying a rule involving the silver ratio. He developed a formula that looks something like this. The radius of a planet's orbit is related to the radius of the previous planet's orbit, scaled by a factor involving the silver ratio. To test this, Gerby started with Mercury, the innermost planet. Using its known orbital distance as a baseline, he applied his formula. The result, a predicted distance for Venus's orbit that was astonishingly close to its actual measured value. He then repeated the process, using the calculated value for Venus to predict Earth's orbit, then Earth's to predict Mars, and so on, moving outwards through the solar system. The results were striking. For the inner planets Mercury, Venus, Earth, and Mars, Gerby's silver ratio model predicted their orbital distances with an accuracy of over 99%. Think about that for a moment. A single, elegant mathematical constant seemed to unlock the layout of our cosmic neighborhood. But the model didn't stop there. It also worked surprisingly well for the gas giants Jupiter, Saturn, Uranus, and Neptune. While the accuracy was slightly less than for the inner planets, it was still incredibly high, far better than what you'd expect from random chance. The model even accounted for the asteroid belt, positioning it right where it should be between Mars and Jupiter. It treated the asteroid belt, specifically the dwarf planet Ceres, as a missing planetary step in this grand cosmic staircase. So, what does this all mean? If Gerby's hypothesis is correct, it suggests that the formation and evolution of our solar system were guided by a deep, underlying mathematical principle. It implies that the forces at play during the formation of the protoplanetary disk gravity, resonance, and the distribution of matter naturally settled into a stable, harmonically spaced arrangement. This isn't just a numerical coincidence. It could be a fundamental feature of how planetary systems organize themselves. This idea of orbital resonance is key. We know that gravitational interactions between planets can create stable, repeating patterns over millions of years. For example, for every 2 orbits Jupiter makes, Saturn completes nearly 5. These resonances help to clear out or stabilize orbits. Gerby's model suggests that the silver ratio might be a sort of master resonance, a global organizing principle that shaped the entire system. Of course, like any bold scientific idea, Gerby's hypothesis has its critics and requires more investigation. The scientific community is rightfully cautious. We need to understand the physical mechanism that would cause a system to favor the silver ratio over any other mathematical relationship. Is this a unique feature of our solar system, or could it be a universal law for planetary systems throughout the galaxy? Answering that question is the next exciting step. With telescopes like the James Webb Space Telescope, we are discovering and characterizing thousands of exoplanetary systems. We can now begin to test if Gerbe's silver ratio model or similar harmonic laws apply to these distant worlds. If we find other solar systems that follow this same pattern, it would transform our understanding of planet formation from a chaotic scramble into an elegant, predictable process. It would be a monumental discovery, proving that the universe truly does have a hidden mathematical score. In conclusion, Szilard and Gerbe's hypothesis offers a beautiful and provocative vision of our solar system. It revives the ancient dream of cosmic harmony with modern mathematical rigor. By connecting the orbits of the planets through the elegant simplicity of the silver ratio, it challenges us to look at our place in the universe in a new light. It suggests we live not in a random collection of worlds, but in a finely tuned, architectural masterpiece governed by hidden mathematical laws. Whether this hypothesis ultimately stands the test of time remains to be seen, but it serves as a powerful reminder that there are still profound mysteries waiting to be uncovered right here in our own cosmic backyard. The search for order in the heavens is far from over. Thank you so much for joining me on this journey into the harmonic architecture of the solar system. If you found this topic as fascinating as I do, please hit that like button, subscribe for more deep dives into science and cosmology, and share your thoughts in the comments below. What do you think? Is it coincidence or cosmic design? Thanks for watching, and I'll see you in the next video.